Hey everyone, so today we're going to look at examples of projectile questions. In this first example, we are told that a particle is projected from a horizontal plane. We've got the initial speed and the angle of elevation. So let's draw ourselves a little diagram. Okay, like with everything in mechanics, we want to be able to see visually what's happening. It's going to start at point O and land on point A. And we have the initial speed 28 meters per second and our angle of elevation 30 degrees. And this first question wants us to find the greatest height above the plane. So we want to know what this height is at this point. Okay, now at this point, our vertical velocity is going to be 0 because it's at the point it's changing direction. So momentarily, our vertical velocity is going to go from positive, before it goes negative again, it's going to equal 0. So we want to resolve vertically. So we are trying to find the vertical displacement. Now our initial vertical velocity, this speed has a vertical and horizontal component. So if I was just to draw this out as a right angle triangle, we would have 30 degrees here, 28 would be our hypotenuse. We have a vertical component and horizontal component. Now the vertical component is the opposite side of that triangle, that would be 28 sine 30. And the horizontal component, which we may use later, would be 28 cos 30, because that's the adjacent side. So we're going to use this one, the 28 sine 30. And we want to know when the vertical velocity becomes 0. Our acceleration is due to gravity, so that is minus 9.8 meters per second squared, because gravity is acting downwards, whereas this vertical component of our initial velocity is acting upwards. Okay, so they're opposite directions, so therefore they have opposite signs. We don't have the time, and we don't need to find the time for this question, so let's cross that out. So we want a Suvat equation that doesn't have t in it. So that is going to be v squared equals u squared plus 2as. And we're trying to find s, so let's rearrange. We get v squared minus u squared over 2a. So s equals 0 squared minus, now sine 30 is a half, so that's going to be 14 squared over 2 times minus 9.8. So if we pop that into our calculators, we get exactly 10. So this maximum height above the plane is 10 meters. Second part of the question, we want to find the time of the flight, so how long it's taken to get from O to A. So again, we're going to resolve vertically. But this time, we want our displacement to be the same as it was at the start. So S is going to equal 0. Our vertical displacement is going to be 0. Our initial vertical velocity is the same. So we can write 28 sine 30 or 14 meters per second. V, we don't have or don't want this time. Our acceleration is due to gravity again, so it's minus 9.8 meters per second squared, and t is what we're trying to find. So a Suvat equation that doesn't have t in it, that doesn't have v in it, sorry, is s equals ut plus a half at squared, and sub in all our values, so we get 0 equals 14t. A half of minus 9.8 is minus 4.9. t squared. So we've got a little quadratic we can solve by factorising, by taking the t outside, so we get 14 minus 4.9t, so therefore t equals 0. Well, that's going to be at the start, that's when the displacement was 0, so that's this point, okay, or t is going to equal 14 over 4.9, okay, so that's this time. Okay, so therefore t equals 14 over 4.9, which is 2.9 seconds to two significant figures. And then lastly, we want to find the distance of OA. Okay, with the distance. Well, we know how long it takes now. Yeah, we got this time for the whole flight. So now we can resolve horizontally. Okay, we're trying to find that horizontal displacement. Our horizontal initial velocity is 28 cos 30. Now horizontally, because we are ignoring air resistance, there is zero acceleration in the horizontal plane. So your final velocity horizontally is always the same as your initial, and your acceleration is always zero. And we know that time to get to A is 14 over 4.9. So when we use the Suvat equation, S equals ut plus a half at squared, because A is 0, we just end up with S equals ut. S will equal 28 cos 30 multiplied by our time, 14 over 4.9. Okay, so pop that into our calculators. And we get 40 root 3 or 69 meters to two significant figures.